So continuing now, we're going to go the other way around. Now we're going to say, alright, express the points in polar coordinates. You want r to be positive and theta to be between 0 and 2 pi. I'm trying to make this as simple as possible. So this is x and y. Unlike polar, you could use the formula straight, but here you got to be careful because the formulas could throw you off. You really need to plot the points, not for r but for theta. So if I plot a point of 1 to the right, 1 down, that's really the x and the y. This is 1 and this is negative 1. Well, I know how r is. R squared is the square root of 1 squared plus a negative 1 squared. I'm going to give myself more space so I could work easier. So r squared equals x squared plus y squared. R squared equals 2. So when I square root, remember, in polar land, r could be positive or negative. In this case, I'm going to say r equal, it should be plus or minus. I'm keeping it simple by saying let r be positive, so I want the radical 2. This way it really matches my, I'm going to take a point out because that's not enough space, and I'm going to give myself a bit more space. So I could say in this case tan of theta equals, there's theta, the opposite over the adjacent. Notice I didn't use the negative 1 because I want the reference angle. And tan of theta equal 1. The reference angle is actually pi over 4. Now, what is pi over 4 in this quadrant? That is 7 pi over 4. So this is the equivalent of, in r and theta, radical 2. If you rotate to 7 pi over 4 and you move radical 2, you are at the same location. Next example. This says do not rotate at all. So you still, this x and y, I'm mixing things up. Negative 1, 0. These points are very easy to get. And why is that? Because I know if I rotate to pi, I'm lined up with that. And if I move 1 unit, I am at that location. So here, no need to do a lot of work. This is the equivalent of r and theta. R is 1 and theta is pi. And that takes care of business. That's all you have to do. If it's that simple. This point right here, if I plot that, that is at negative 3 radical 3, negative 3. So I could figure out what r is. Well, r squared is negative 3 radical 3 squared plus a negative 3 squared. R squared is going to be 9 times 3 plus 9. R squared is going to equal, what is that? 2736. When I square root both sides, I will always have the option of a plus or minus, but I'm going to choose the positive. We'll talk about the negative later. And you'll notice here, theta. If I say what's the tan of theta, that's the opposite over the adjacent. You'll notice it's positive. That's why we always find reference angle first. What's the reference angle? And if there is a need, I can get there that quickly. 30 degrees, 1, 2, radical 3. Which, the tangent of which angle gives you 1 over radical 3? Tan of 30 is the opposite over the adjacent. So it's pi over 6. But I am in this quadrant. What is pi over 6 in quadrant 3? That is 7 pi over 6. So I could say this point is the equivalent of, you could say equal, it doesn't matter. This is x and y. R and theta, you put r first. If you rotate to 7 pi over 6 and you move 6 units in that direction, you will end up being at the same location. And that's how this works. Now, what if they gave me an equation? And they're doing this because of the way our author sketches the graph. We're going to graph slightly different than that, but we need this for later on, so let's get it out of the way. It says, express the equation in polar coordinates. Well, what do we know? We know that y is r, the sine of theta. So, polar coordinates, you should see no x and no y. This is good enough as an answer. But, do you know how you normally would write y equal f of x? In the polar grid, they like to write r equal f of theta, which means if you could solve for r, they want you to. I don't mind much. This is a fine answer for the homework and the exam, but that's not what you can see on in the back of the book. They would get r by itself. They divide both sides by sine of theta. And if you look at the back of the book for this example, if it is there, that will be 3. 1 over sine is the cosecant of theta. That would be the answer in the back of the book. Both of those are fine. On a test, once you get y and x out of the equation, you're set. What if they have x equal negative 2? Well, I know that x is r times the cosine of theta. And again, this is a fine answer for the homework or the exam. To match the back of the book, you can divide both sides by cosine. And 1 over cosine is the secant of theta. That would be the answer in the back of the book. And if I look at this, x squared plus y squared equals a 16. Well, I know this is r squared based on what I have, and it's right there if you ever want to look at it. Right there. You could always use that. That indicates that r squared equals 16. That's fine. And r should equal plus or minus 4. Most likely, you would notice the back of the book will write r equal 4. That's acceptable as well. That's not a problem. When we get to the graphing, I'll show you that's the same thing. And if I move to example D, I will say this is r times the sine of theta. This is r times the cosine of theta. On a test, I am more than happy with this answer. But again, they will solve for r. They will say r the sine of theta equals r squared the cosine of theta. And what they do, they'll get 0 on one side. They'll factor an r out. R equals 0, or r cosine of theta minus sine of theta equals 0. So they move the sine over. And they would divide both sides by cosine. And sine over cosine is the tangent of theta. So the back of the book will have those two answers. They might not include r equals 0. That's okay. And again, for what we need, this is sufficient for now. That's all you need. And what if they gave me r and theta and they want me to go to x and y? Well, here we have an advantage. The only way I could get around an r and a theta, it has to be r times the cosine of theta to get an x, and it must be r times the sine of theta to be a y. So that gives me a starting point on every one of these problems. So here I'll say, okay, r equals 3. If I square both sides, I'll get r squared equal 9. And isn't r squared x squared plus y squared equal a 9? So that's an equation of a circle. And the next problem, they have theta equal pi over 3. The way to connect theta and x and y, I notice it's right there. If I'm given an angle, I know that tan of theta equals y over x. Tan of 60 degrees, again, if there's ever a need draw that triangle and that solves the problem for you. And tangent of 60 degrees is the opposite over the hypotenuse, the opposite over adjacent. And if you cross multiply, this says y equal radical 3x. So that's a line. And that's what they're getting at. They want you to make the connection between those. Again, when we get to the graphing, I'll show you another way of doing this. Looking at this, converting from r and theta, there is no secant. I need sine and cosine. So I know what to do. I need to write this as a cosine. If I cross multiply, r the cosine of theta equal 4, and there it is. I know that r the cosine of theta is x, and that would be my answer. The deal is to eliminate r and theta out of the equation completely. And if I look at example D, I notice, again, the starting point for me is I see a sign with no r. To get an r there, I multiply both sides by r. This will be r squared equal 4 times r the sine of theta is y. Isn't this x squared plus y squared? Now, this is sufficient for me. That's all I need. What they do, they complete the square and show that this is a circle. They take half of the middle number, which is 2, and they square it. And they say this is x squared plus this is y minus 2 squared equal a 4. So we know that's a circle with a radius of 0, with a center of 0, 2, and a radius of 2. You don't have to worry about that yet. And if I look at my last two examples, they're not going to make much sense in the rectangular coordinates, but we're going to proceed. Where do we start? We start with this. For me to eliminate a sine or cosine, there must be an r there. So I need to multiply both sides by r. R squared equals 2r minus r the cosine of theta. This is x squared plus y squared. This is 2r, and this is x. So this is x squared plus x plus y squared equals 2r. And to get rid of this, I would square both sides. I need to get rid of r and theta completely. So this equation doesn't make a lot of sense in rectangular coordinates, and that's accepted. That's going to be 4r squared, and r squared is x squared plus y squared. When you see the graph of this, you're going to know why that doesn't make any sense in rectangular coordinates, but I could convert still. And if I take the last question, part F, and I convert, I would cross multiply. So I know this is x. That's very good. You can't leave the answer with r and x. You need to get rid of r and theta. So solve for r. And to get rid of this r, I need it to be squared. If I multiply by r, this will pick it up. So I have an option. Either multiply by r or square both sides. And it turns out squaring both sides is the better way to go. R squared is x squared plus y squared. And the right side is 4 minus x squared. On a test, this is all I want. But they proceed to show you what this is the graph of. That's 16 minus 8x plus x squared. X squares cancel out. So I'm looking at y squared. If I switch those, 8x equals 16 minus y squared. If I divide by 8, and I would know that this is a parabola. Again, this will be the answer in the back of the book. This is all we need for our purposes. As far as graphing, we're going to do things totally different. And this is all there is about converting polar coordinates back and forth. And that concludes this section.